Okay, so today we're solving quadratic equations using square roots. The steps are fairly simple. We're solving these algebraic equations very similar to the way we normally solve algebraic equations. We just got to throw one extra step in there, and that's taking the square root. So the first example asks us to solve 2x squared equals 8. Now if that was just 2x equals 8, what would we do? Divide. So we're going to do that again. We're going to take and divide both sides by 2. We get x squared equals 4. Here's the trick. There's two numbers that when you square them, you get 4. What are they?
2 and negative
2
2.
and negative 2, or plus or minus 2. Because 2 squared is 4, and negative 2 squared is 4. So a lot of times we're going to have more than one solution. Everybody good so far? Now, pretty much the only time that won't happen is when you have an equation like this. M squared minus 18 equals negative 18. What's our first step to solve?
Subtract 18. Or no, add 18.
Add 18 to both sides. M squared equals 0. And there's only one number that when you square it, you get 0. What's that? 0. So that's about the only time in these that you'll have one solution, is when you have your square equal to 0. But there's a third possibility. How do we solve this one?
Subtract 5.
Oh, no. You're supposed to subtract.
Trying to get b by itself.
Oh.
So we're going to subtract 12.
Subtract 12.
Gives us negative 7, right?
No two numbers multiplied by each other is negative.
That's right. You can't take the square root of a negative number. So this is a no solution situation. Make sense?
Mm-hmm.
All right, now let's make it interesting.
That sounds also funny.
Keep your skepticism off the video. What's our first step?
You would divide by 4.
Now, it's actually going to be easier to leave this as a fraction. Because now I want to take the square root of both sides, right?
Yes.
And I know I'm going to get two solutions, a positive and a negative. What's the square root of 9 over 4?
3 over 2.
3 over 2. You just take the square root of the top and the square root of the bottom. Because 3 over 2 times 3 over 2 is 9 over 4. So not so bad after all, is it? When you're taking the square root of a fraction, you take the square root of the top over the square root of the bottom. Not so difficult, right? Alright. Everybody got their calculator? Everybody know where the square root button is? Okay, first step in solving this equation.
Add 11 to both sides.
Add 11 to both sides. Gives us 3x squared equals 18. Next step.
Divide by 3.
Divide by 3. We get x squared equals 6. Then what?
Square root.
Let's take the square root of both sides. What's the square root of 6? Give me two decimal places.
2.44.
So good with the raising of the hand.
Wait, we need to round it.
And we need to round it properly to
2.45.
2.45. I think if you had raised your hand, you might have rounded it properly. I think the two went together. Your hand goes up, you know the number has to bump up, and you would have had it. But alas, got it instead.
That's funny.
Good. Yeah. All right. Let's throw in a little strangeness. What's our first step in this equation?
Do the distributive.
Can't do that because of that square. If I wanted to use the distributive property, I'd have to multiply out x minus 4 times x minus 4 first. And I don't want to do that. It's too much work because then I want to be able to use my square root property. Yes?
Divide by 6.
Divide by 6 instead. That leaves me with x minus 4 squared equals 7. Now here's where it gets a little tricky. We know we got to take the square root of both sides, right?
Mm-hmm.
But before I plug that into my calculator, I'm just going to write plus or minus the square root of 7. Okay? Because I know that when I take the square root of 7 on my calculator, that'll give me the decimal answer that I need. Okay? That part I'm not worried about. What would be my last step?
The 2.
Add the 4.
Add the 4. The 2. What 2? That's
No.
we took care of that by taking the square root of both sides. That already disappeared when we took the square root of both sides. Okay? Now we're down to x minus 4 equals plus or minus radical 7. So Spence and Maria said we need to add 4 to both sides. So that gives us x equals 4 plus or minus radical 7. Now, what's 4 plus radical 7?
6.65.
6.65. And what's 4 minus radical 7?
-6.
No. That would be negative 4 minus radical 7. Maria? 1.35. Okay. Since that 4 doesn't have the plus or minus attached to it, they're not going to be perfect opposites. Okay. Instead, we've got something like 4 plus radical 7, which is approximately 2.65. And we've got 4 minus radical 7, which is approximately 2.65. Okay, that's what we're seeing with the plus or minus there. That make sense? That make sense?
Yeah.
Does that make sense?
Yeah, a little.
Okay, so we've
How
got...
do you get from the purple part, like from the
We're colorblind
red
now.
part,
Okay.
to the answer?
Okay, so in our calculator, we do 4 plus square root 7. And we get our answer. That gives us about 6.65, right? Then we do 4 minus square root of 7
Okay.
as a separate problem. Okay? Make sense? Okay. Now, suppose you're at an ice hockey game. Yeah, ice hockey. It's always fun. I went to an ice hockey once, and there was an ice hockey game once, and there was a fight. So that made it worth it. And I caught a puck. That was cool, too. So during the ice hockey game, a remote-controlled blimp flies above the crowd and drops a numbered table tennis ball. The number on the ball corresponds to a prize. Use the information in the diagram to find the amount of time that the ball is in the air. So the diagram tells us how far the ball travels. So first of all, let's think about this. We got our basic vertical motion problem is this, where v is the initial velocity and s is the initial height. Now, what's the initial velocity of a ball that's being dropped?
0.
0. When it's being dropped, there's no velocity. Okay? So, there's a difference. If I take this water bottle and let go, boom, had 0 initial velocity, right? As opposed to if I take it and throw it, then it has some initial velocity, right? And so it hits the ground a lot faster. So this ball is just being dropped, so it has 0 initial velocity. So that term really is just going to kind of disappear. What's the initial height of the ball? 45 feet. And we want to know how long it's in the air. Well, where is the ball caught at?
17.
17 feet. So we want to set h equal to 17.
And what do you minus 45?
Subtract 45 from both sides gives us negative 16t squared equals negative 28.
Then divide.
Then we divide. And we get 28 divided by 16, which is 1.75.
Yep.
Then we take the square root of both sides. What's the square root of 1.75? Maria?
1.32.
Approximately 1.32. Do we care about the negative 1.32? No, because this is a time, and we're not traveling backwards in time. We're traveling forward in time. So it is in the air for approximately 1.32 seconds.
That is so much easier than I expected.
Does that make sense?
Yep.
Now notice this only worked because we didn't have an initial velocity. If we had an initial velocity, then we're going to have a t1 in there, and we're going to have some more steps to do. So why don't we set you up with one to practice? Oh. How about you work out this one on your own, then we'll unpause the video and see how you did. Hey, what was our first step? Yes.
By 2.
Divide both sides by 2 gives us
9.
x minus 2 squared equals 9. Next step. Yes.
We would to get x minus 2 out of parentheses, you do x minus 2 equals plus or minus square root of 9.
Yes. And what's the square root of 9?
3.
3. Okay, then the next step.
Oh.
Add 2 to both sides. Gives us x equals 2 plus or minus the square root, plus or minus 3. So we do 2 plus 3, which gives us 5. And we do 2 minus 3, which gives us -1. So our solutions are 5 and -1. Make sense? Any questions? All right.